Hi everyone, I wanted to make this quick video to help describe how the octet rule can explain how atoms ionize. So first, let's remember something about electron configuration. For atoms in the ground state, that's the lowest energy state, electrons will fill the shells or orbits such that the lowest energy levels are filled first. Let's quickly take a look at the periodic table, and I'll remind ourselves what an electron configuration is and what ground state is. Let's take an example of a sodium atom, which is right here. Here is its electron configuration, and it is 281, meaning that we have 2 electrons in the first shell. That's when it's completely full. It will then start filling up the second shell and fills it up with 8 electrons. Then it is completely filled, and then we have 1 additional electron. That is the ground state electron configuration for sodium. Now this brings us to the octet rule, which is about atoms in their attempt to gain stability. Will either gain or lose electrons so that their valence shell is completely filled. So our last example of sodium was 281. This outer shell is not completely full. So in order to complete that last shell, we either would have to add 7 electrons here, making it 288, or either lose an electron, making it 28. Now, which is simpler? Well, it is simpler to lose 1 electron than to gain 1. So we would lose that 1 electron, acquire an electron configuration of 2-8. But now we have to consider something else. Let's go to the next slide. Now the electron configuration is 2-8. Now remember, it was 281, meaning that it had as a total 11 electrons. It also had 11 protons, and this element was neutral. Now the element has only 10 electrons. It still has 11 protons, making it have a net charge of +1. So now we have sodium. Let's put it up here. Sodium with a +1 charge. It has now become a cation. And it only became that cation because it wanted to achieve the octet rule. On the next slide, we'll take a look at what would happen with a nonmetal. So here we have the periodic table, and in the upper right-hand corner we have our nonmetals. Let's zoom in on one. And let's take an example of oxygen. That's a very common one. Oxygen is right here. And oxygen has an electron configuration of 2-6. It has 8 protons. Let's go to the next slide and look deeper at that. Okay, again, here's oxygen. Its electron configuration is 2-6. It has 8 protons, 8 protons. It has 8 total electrons. Its electron configuration is 2-6. But the octet rule says that the outermost electron shell wants to be full. So to make this valence shell full, we could either add 2 electrons or remove 6 electrons. Now, which would be simpler? Well, the simplest thing would be to actually add 2 electrons versus removing 6. This would therefore give us an electron configuration of 2-8. That gives us 8 protons, 10 electrons, and a net charge of 2-. And look at there, -2. Now, seeing that we're at it, let's investigate what happened to both oxygen and sodium as they ionized to achieve their stable octet. And, well, what happened with oxygen? Remember, oxygen had 8 protons. It had an electron configuration of 2-6, which then became 2-8. So it had 8 protons, and it then had 10 electrons. And again, it had an electron configuration of 2-8 after it ionized. Okay, so it had a charge of -2. Sodium, conversely, started out as 2 281. It had 11 protons, and so it was 281, and when it ionized, it lost that last electron, so it ended up with 10 electrons as well. But it ended up with a +1 charge. So the -2 charge can be seen right here. The +1 charge can be seen right there, called oxidation states, by the way. But now let's take a look at this. There is an element that already has a stable outermost shell, a stable octet. And I'm trying to grab a red pen. There it is, 2-8. So in inspecting the electron configurations after they ionize, which element do they now resemble? Well, it resembles neon, which is a noble gas. So we could extend that statement and say that every element would like to achieve the electron configuration that resembles a noble gas. Now, is oxygen converting into neon? No. It's as if oxygen at Halloween put on a mask that made it look like neon, but deep down it was still oxygen. And the same for sodium. Sodium, in losing an electron, put on a mask that makes it look like neon, but underneath it is still sodium. So the octet rule helps explain why atoms ionize. Oh, and I almost forgot. If in fact the octet rule is not met and an atom has to gain or lose electrons, those elements will be reactive. Now the ones that are only going to gain one electron or lose one electron, for instance, let's take a look here, elements of group, straighten this out, elements of group 1 or group 17. The ones in group 1, being right here, tend to lose one electron very easily, while the ones in group 17 tend to gain one electron very easily. Means that they are very, very, very likely to react, sometimes violently.